Welcome back. In this hands-on demo, we're going to apply security groups and network access control lists, NACLs, in a real-world AWS scenario. So far, we've discussed how security groups operate at the instance level, controlling inbound and outbound traffic for individual instances. NACLs work at the subnet level, acting as the first line of defense in a VPC by allowing or denying traffic at the subnet boundary. But understanding theory isn't enough. Let's set up a practical use case to see how these two security layers work together. We're going to launch a web server in a public subnet. The web server needs to be accessible from the internet via HTTP port 80 and SSH port 22 to install the web application. The NACLs will add another layer of protection at the subnet level. By the end of this lesson, you'll understand how security groups and NACLs differ in operation, how to configure both security controls for a real application, how to test traffic behavior in different scenarios. Let's get started. Step 1. Launching our EC2 instances. Before configuring security groups and NACLs, let's launch the resources we'll use in this demo. Open AWS Management Console and go to the EC2 dashboard. Click Launch Instance, then Configure. AMI, choose Amazon Linux 2. Instance type, choose T2 Micro. Network. Select your existing VPC or use the default VPC. Subnet. Choose the public subnet for the web server. Security group. For now, we'll allow only SSH port 22 and HTTP port 80. Key pair. We won't be needing one, so we will proceed without a key pair. Step 2. Connect to the EC2 instance. We will be connecting to our instance through the EC2 Instance Connect. Install a simple web server using Yum. Test the web app. It should display Hello World. Modify the security group. Go to the security group section in the EC2 console. Edit the inbound rules of the security group attached to the instance. Remove the HTTP rule, port 80. Test the web server again. Refresh the browser. The connection will fail, demonstrating how security groups control access. Re-add the HTTP rule. Add the HTTP rule back to the security group. Refresh the browser. The connection will succeed again. Now let's remove the SSH rule and connect to our instance. Go to the security group section in the EC2 console. Edit the inbound rules of the security group attached to the instance. Remove the SSH rule, port 22. Head over to your instance and try connecting via EC2 Instance Connect. This will not work because we have already closed the SSH port. Now add the SSH rule to your security group and try connecting again. We can connect. Step 4. Configuring NACLs, subnet level firewall. While security groups control traffic at the instance level, NACLs, network access control lists, control access at the subnet level. Think of them as a security checkpoint at the entrance of a neighborhood where all traffic is reviewed before reaching individual houses. Unlike security groups, NACLs process rules in order, from the lowest numbered rule to the highest. Once a packet matches a rule, AWS stops checking and applies that rule, ignoring any rules below it. If a deny rule is placed before an allow rule, traffic will be blocked even if an allow rule exists further down the list. Keeping that in mind, let's configure the subnet NACL of our EC2 instance correctly. Step 1. Identify the subnet, navigate to your EC2 instance, and select the associated subnet. Let's rename it for easy identification. I will be calling mine my demo subnet. Create a custom network ACL. Go to the Network ACL section in the VPC console. Create a new network ACL for the default VPC. Now associate the created subnet network ACL with the subnet for your instance. Step 2. Test connection. Add inbound and outbound rules. 1. Rule 100. Allow HTTP port 80 from anywhere. This test will fail because the instance's outbound rules in the NACL do not allow traffic to leave. 2. Now add an outbound rule that allows all traffic to leave the network. Test the connection, it will succeed. 3. Let's make some changes. Rule 100 to allow traffic on port 80 and Rule 200 to deny all traffic. The connection will succeed because rule evaluation follows a first match principle where the first rule that matches the traffic is applied and subsequent rules are ignored. 4. Let's try another example. Rule 100 to deny traffic and Rule 200 to allow all traffic on port 80. The connection will fail because of the rule evaluation. 5. Now, let's clean things up. We would delete the Rule 200 and allow traffic on the port 80 for Rule 100. In this demo, we created security groups for a web server, configured NACLs to restrict subnet-level traffic, tested connectivity to see how security groups and NACLs interact. What did we learn? Security groups filter traffic at the instance level. NACLs apply rules at the subnet level. If both allow traffic, the request succeeds. If either blocks traffic, the request is denied. This setup follows AWS best practices, ensuring a layered approach to security. In the next video, we'll wrap up AWS networking with real-world use cases and best practices. See you there.